Welcome, class. This lesson is called Place Value. Make sure before you start this lesson that you have your math notebook out. Turn to the next clean page. You have a pencil and an eraser. Occasionally, I'm going to ask you to pause the video and do some work on your own and then follow along with me. So make sure that you're prepared to do that work yourself in your math notebook. All right. Today's lesson is place value. We write numbers using only 10 symbols. So 10 symbols that we call numbers. We call them digits. Now, why do you suppose we have 10 symbols and not 12 symbols or 15 or 20 or 60 symbols? Well, most people believe that we chose that number 10 because, well, take a look at your hands. What do you notice? We have 10 fingers, and as people evolved this idea of counting, it's most likely that they looked down at their hands and used their fingers to count small numbers. It's no accident that we call the numbers digits. Digits is also a name for fingers. So there are 10 symbols, 10 digits that we use to count, and where we place those digits is important. The digits that we use are called Hindu Arabic symbols. Now, these symbols actually came from India in the 6th or 7th century and were advanced and evolved by mathematicians in the Middle East. Later on, they were brought to Europe through the writings of a Middle Eastern mathematician, one in particular named Al-Khwarizmi. Al-Khwarizmi. In 1830, Al-Khwarizmi wrote an important book called Al-Jabra, which means the restoring of broken parts. And that is where we get the word algebra now. So Al-Khwarizmi kind of brought these writings to Europe in about 1830 or so, and those symbols were then advanced and changed over time. This is kind of a cool drawing. You might have some fun copying down some of these symbols, but you'll see up on top those are the Brahmi symbols and then the Hindu symbols that were originally developed in India, including the symbol for 0, and then evolved and changed into the symbols that we use today. Well, we can use these digits on their own to count up to 9. So you'll notice on top that there's a symbol 0, right? And there's no beads for that. And then as we count 1, 2, 3, 4, 5, 6, 7, 8, 9, there are symbols for all of those things. But what symbol do we have to represent the number that comes after 9? What symbol do we have to represent the number 10? Well, when we get to 9 or more items, we start a new column. That's the tens column. We write down how many tens we have, and then how many ones we have, or what we call units most often. So you'll see here that there's two numbers, a 1 and a 0. The 0 is in the units column. The 1 is in the tens column. So, for example, this is how we write 12, the number 12. It says we have 1 10, that's a 1 in the tens column, and that 1 represents 10 beads. And we have 2 ones or 2 units in the ones column or the units column. And put them together, that makes 12. And see down here, there's the blue 10 and the red 2. So we can write this as 12, the number 1 and 2, or as partial products. Partial products means 10 plus 2. That kind of, let's see here. So, another example here, we have 35, which means 3 tens and 5 ones. So that's a 3 in the tens place and a 5 in the ones place. Well, what if we have 110 but we don't have any units or any ones? We show no ones by putting a 0 there. So you'll notice with the beads, you see 10 beads, and then you see nothing next to it. And we represent that as a 1 in the tens place and a 0 in the ones place or the units place. That's the number 10. So we put a 0 in the units place. That's the red, the ones place. I'm using both of those words, you'll notice. It's because those words are both used interchangeably, and you'll see them both used in kind of work that you're doing and things that you're reading. And I want to make sure that you know they mean the same thing. So here we have a partial product, the partial products. It's 10 plus 0. How about 100 or more? When we have more than 99 items, we start another column called the hundreds column. Now we need to show how many hundreds, tens, and ones. So we show we have 100, 4 tens, and 3 units, or 3 ones. You can also write that as 1 times 100 plus 4 times 10 plus 3 times 1. That's the partial product. So you could say 100 plus 40 plus 3. So for example, 369 means 300 and 6 tens and 9 ones, or 9 units. So here we have the partial products, 300 plus 60 plus 9. Or 104, which is 100 and 0 tens and 4 ones. So we can put a 0 if there are no tens. 104, I should say. It's important not to use the word and in the middle of a number. So I wouldn't say 104, I would say 104. That and is used for something different that we'll talk about later on. All right, 1 unit. So there's 1 unit. Now I'm going to write it both ways. Now I want you to pause the video here, and I want you to make a little drawing that looks kind of like this. So you've got 2 columns, a tens column and a units column. Go ahead and pause the video and make a little drawing like this in your math notebook. All right. Now, you can sketch along, but you're going to use that drawing in a minute here, but I just want you to have that ready. So I'm going to show you 1 unit, 2 units, 3 units, 4 units, 5 units, 6 units, 7 units, 8 units, 9, and 10. And when we get to 10, you'll notice that we have no units in the ones place, and we move it over to the tens place because 10 units equals 110. You see that? 0 in the units place, 0 in the ones place, and 1 in the tens place. There we go. 110, 2, 3, 4, 5, 6, 7, 8, 9. Now I want you just to think and predict. Go ahead and even write it in your math notebook if you want. What's going to happen when I add another 10? Remember, I can never fit more than 9 inside of any column. That's all the digits we have. We only have 9 symbols. So what's going to happen, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are all the symbols we have. What's going to happen when I add another 10 to that box? Well, I'm going to add a hundreds column. That's 10 tens equals 100. Now, you'll notice they look a little bit different. If I were to squish those blue together really tightly, I'd get a nice square like that. So you noticed up in the top left, I've added another column, 100. There it is in the column 100. Did you predict correctly? Did you guess that I was going to add another column for the hundreds place? So here I have 0 units or ones, 0 tens, and 100. Sure is a lot easier to write those numbers than it is to draw all those little squares, isn't it? 200, 3, 4, 5, 6, 700, 8, 9, 1000 equals 1,000. In fact, 1000 and 1,000, if you think about it, 1000, that'd be like 10 for 10 and 00 for 100. That's 3 zeros. When we write 1,000, we do the same thing. 1000 and 1,000. The same thing. Of course, they look a little different in my picture here. If I squished those red squares together, they would make that green cube. There's that 1,000. So I have 1,000 in the thousands place. So I write that as a 1 in the thousands, 0 in the hundreds, 0 in the tens, and a 0 in the units.